So every developer, at some point, has to ask themselves this question: which database do I use? It's a huge decision, one that can literally make or break a project, a startup, you name it. Today, we're going to dive into how the pros think about this, how they move beyond the simple answers to make the right call in a world that is just full of options.
You know, the idea for this whole thing actually came from a question I saw on Reddit. It's from a startup founder, and it is so real, so relatable. They built their product on a simple, cheap NoSQL database. And now they're at that point where they're wondering, is it time to switch? And that question, it gets right to the very heart of the modern developer's dilemma.
All right, so let's really try and get inside this founder's head. They're at a serious crossroads, and the choice they make right here, right now, could totally change the future of their company. Okay, so here's the deal. They've got a successful SaaS product, revenue is growing, their current database, DynamoDB, is ridiculously cheap. We're talking less than $2 a month, but it's unstructured. Now, moving to a traditional SQL database like Aurora would give them way more flexibility to add new features down the line. The catch? The cost would skyrocket to $170 a month. So, what do? Do you stick with what's cheap today, or do you invest in flexibility for tomorrow?
Now, whenever a question about trade-offs like this comes up, developers have this, old rule book they tend to pull out. It's been the go-to guide for designing distributed systems for decades. But as we're about to find out, that old rule book, it might not be the right guide for today's problems.
And that rulebook, yeah, it's the famous CAP Theorem. It's this foundational idea that says when you're building a big system, you want three things. Consistency, meaning everybody sees the same data at the same time. Availability, meaning the system always answers your requests. And partition tolerance, meaning it doesn't fall over if parts of the network go down. The theorem's big claim is you can only have two.
Sounds pretty neat, right? A simple trade-off. But the reality of building software today is, well, it's rarely that simple. Which brings us to a really important question. And this is where things get really interesting, thanks to researchers like Martin Klapman. First off, the word availability in the theorem doesn't mean what you think it means. The theorem says a system is available if it eventually responds. That could be a week from now. In the real world, we have a different word for that: down. And second, this whole pick two thing is kind of misleading. Because in today's world of cloud computing and messy networks, you can't just opt out of network failures. You have to be partition tolerant. It's not really a choice at all.
So, what's the bottom line here? It's that while the CAP theorem might be technically true in its own little academic bubble, it's just not a very helpful tool for making real-world decisions. It doesn't match up with what developers are actually dealing with day to day. Okay, so if the CAP theorem isn't the right tool for the job, what is? Let's get away from all that abstract theory and talk about the actual concrete trade-offs our founder, and really all of us, are facing every single day. And this right here, this is the heart of the debate. SQL databases like Aurora, they're forgiving. You don't have to know every single question you're ever going to ask them up front. That makes them awesome for ad hoc stuff, for analytics, for when the business team suddenly needs a new report. On the flip side, you've got NoSQL databases like DynamoDB. They are built for pure speed. They are incredibly fast and cheap for the things you planned for. But you have to plan for them perfectly.
And that brings us to a much more useful way of thinking about this, something Klapman calls delay sensitivity. Instead of a simple pick two, this asks a much more practical question. How much does my query slow down when the network gets flaky? It shifts the whole conversation from these abstract ideas to something we can actually measure: latency.
Okay, so what does that actually look like? Well, this table breaks it down. If you want the absolute strongest consistency, linearizability, where your database acts like one single perfect machine, you're going to be really sensitive to network delay. But if you can relax those requirements a bit, maybe to something like causal consistency, your operations can suddenly become almost immune to network delay. They stay fast, even when the network is slow. You see? It's not a simple choice. It's a whole spectrum of trade-offs.
So, you have this whole spectrum of choices, all these different trade-offs. What in the world do you do? Well, the answer more and more is not to pick just one, but to embrace all of them.
The answer is something called polyglot persistence. And the idea is really simple. A modern application shouldn't be squeezed into a one-size-fits-all database. Instead, you should deliberately use multiple different databases, picking the absolute best tool for each specific job.
And this radar chart just perfectly shows why this idea makes so much sense. Just look at the different shapes. There is no database here that's a perfect circle that maxes out every single category. Nope. PostgreSQL is amazing at complex queries, but it doesn't scale like Cassandra. Redis is easy to run, but its query power is limited. Each one has its own unique fingerprint of strengths and weaknesses.
This heat map makes it even more obvious, right? The dark blue spots are where a database really shines, and the light blue spots are where it doesn't. You can see at a glance that if you're building a complex app that needs search and transactions and caching, you're probably going to need to pick from a few of these different columns.
And look, this isn't just some academic theory. This is how the absolute biggest systems on the planet are built. Netflix, Uber, Shopify, they don't use just one database. They use a whole portfolio of them, each one carefully chosen and optimized for a different piece of their massive operations.
Okay, so what does all this mean for you, whether you're that startup founder or developer at a huge company? It means you need to stop thinking about picking a single database and start thinking about building your data fleet.
I love this analogy. It's so simple, but it's really powerful. You wouldn't use one car for everything, right? You're not going to take a Ferrari off-roading, and you're not going to try to win a Formula One race with a moving truck. You build a fleet of vehicles, each one specialized for a specific job. Your data architecture should be exactly the same.
So here's a simple little framework you can use. First, identify the job. What are you trying to do? Transactions, caching, search? Then pick the right vehicle for that job, the database that's optimized for that one task. Next, you combine them all to build out your fleets. And finally, and this one's really important, you have to accept the overhead. Managing a fleet of different databases is more work than managing just one, for sure. But the payoff in performance and flexibility is almost always worth it.
And let's bring it all the way back to that Reddit thread we started with. Here's a developer who actually made the switch. They ripped out DynamoDB and moved to SQL. And what happened? A major simplification of their code. Using the right tool for the job didn't just make the database better, it made their whole application simpler.
And you know, this isn't some fringe idea anymore. This is the new normal. Research shows that over 60% of companies using modern microservice architectures are already doing this. They're already using multiple databases. This is just how modern software is built.
So we're going to leave you with this final thought. The next time you start a project, maybe the question you should be asking isn't which one database is the best, but instead, how many different databases does my application need to be the best it can be?